The process where water keeps going deeper into the ground is known as infiltration. The flow of water changes the moisture content in soil. Based on the distribution of moisture during this process, we may demarcate 4 moisture zones within a soil profile. A thin layer of saturated zone is the topmost moisture zone. Soil within this zone is saturated, where its pores are fully filled with water. The saturated zone is often a few millimeters thick. Transition zone is located below the saturated zone. Within this zone, water content in soil decreases sharply with depth. Beneath the transition zone, soil moisture content starts to stabilize. The change in water content with depth is small, and the soil stays unsaturated. This zone is also known as transmission zone. Underneath the transmission zone, we have a wetting zone. This is where the water content in soil decreases sharply with depth. The wetting zone is bounded by wetting front. The movement of water across this boundary is not observed, and discontinuity in terms of soil moisture content should be expected. When studying infiltration, we are often interested in both infiltration and fill capacity. Infiltration capacity defines how fast the ground can absorb the water, while fill capacity defines how much water can be retained by the soil. Perhaps it is easier to understand the concept of infiltration capacity and fill capacity and some possible infiltration scenarios by using the following model. First, let's look into the case where rainfall intensity over the catchment is low. As soon as the rainwater reaches the ground, the soil absorbs it and allows it to infiltrate deeper. By the time when another batch of rainwater hits the ground, some pores in soil are already free of water and ready for another round of infiltration to take place. When the rainfall intensity is high, the soil may not have enough time to transfer the water downward before allowing the newly supplied rainwater to infiltrate. As a result, some water will stay on the ground surface instead of getting into the soil and then being transported away as runoff. The soil itself has limited space to store water. When the volume of water entering the ground exceeds the fill capacity, the excessive water that successfully entered the soil will be transferred further down under the gravitational force. Eventually, the water will meet the underground water storage and contribute to the groundwater flow. Generally, the actual rate of infiltration should equal to the rainfall intensity, so long as the infiltration capacity is not exceeded. The infiltration capacity is hugely influenced by the soil properties, ground surface condition, and fluid characteristics. The texture, structure, and permeability are among the soil properties that define the infiltration capacity of soil. Soil types under high infiltration class have several similarities, such as high permeability and cohesionless by nature. Some examples of soils under this category are deep sands and well-drained aggregated soils. In contrast, water drainage process is slow in cohesive, clayey soils, and this leads to very low infiltration capacity. Moreover, dry soil can absorb more water than wet soil. This is also why under most situations, the infiltration capacity is the highest at the beginning of storm event and decreases exponentially with time. When raindrops hit the ground, the impact may disrupt the arrangement of particles in topsoil. Fines may be displaced somewhere else. There is a possibility where these fine particles block the pore spaces and reduces the infiltration capacity of site. It has been noticed that such phenomenon is less likely to occur when the surface is covered with vegetation. Therefore, we can say the surface condition plays its role in affecting the infiltration capacity of soil underneath. Sometimes, the water itself may influence the infiltration capacity. If water consists of large amount of impurities, they may block up the pores in the process of infiltration, especially when the impurities are mainly fine particles. As a result, the infiltration capacity will be reduced. Thank you for watching. If you find this video helpful, please share it with your friends. We'll see you guys soon. Goodbye.